Hello, everyone, and welcome to Jack's Math Notebook. This is our 8th video in a series of videos related to solving a system of two equations. And this time we're going to use the substitution method, and we have two big examples to illustrate that point. However, it is highly recommended that you look at the previous videos, so by now you will have a real good confidence, a real good understanding how to solve a system of two equations. And so without further ado, let's go into big example one, in which we have x is equal to 3y minus 1 and x plus 2y is equal to 9. And so in this case, since we're using the substitution method, x right here is already isolated, meaning that x is the same as 3y minus 1. And if that is true, why not replace this x with the 3y minus 1, in which we did right here? And so now instead of x plus 2y is equal to 9, we're just going to say 3y minus 1 plus 2y is equal to 9. And now we have just one variable to work with. We're only going to work with y for now, find out what y is, and that will help us find out what x is later on. And so what we're going to do, we're going to combine the like terms at 3y plus a 2y, and that will give us a 5y. And so now we have 5y minus 1 is equal to 9. And in order to balance the equation, meaning that we're going to get variables like y on one side and numbers like 9 on the other side. And so what happens here when we do that, we have 5y is equal to 10, and that begs a question. What number times 5 will give me 10? And you're right, that answer is 2, because 5 times 2 would give me 10. Or you could just simply divide by 5 on both sides and you will arrive at the same place, which is the number 2. And let us plug in this number 2 in the easiest equation. Now I choose the top one, in which we're going to have x is equal to 3 times 2 minus 1. We know that 3 times 2 is 6. Subtract 1, and x is 5. Wonderful. So we have it. So, but just to make sure, let's plug it in, because we know that 5 is equal to 3 times 2 minus 1. That's good. And 5 plus, and I know that looks like a Christmas tree, but that's actually a plus sign, ink blot, that kind of thing. So 5 plus 2 times 2, which is 4. So 5 plus 4 is equal to 9. So this one checks out. And our solution is at 5, comma 2. Yes, we got it. Let's go to big example 2 and work it out the same way, in which we have 5 is equal to a negative x plus 5. Y again is equal to a negative x plus 5. And we have x minus 4y is equal to 10. And so now what we're going to do, we're going to replace this y with a negative x plus 5, because y is already isolated. So now wherever we see a y, we're just going to replace it with a negative x plus 5. And we're going to do that to this equation right here. You see that y? Well, you're gone, y. We're going to replace you with this negative x plus 5. I know I said it many times, but repetition really works, y'all. And so now we have x minus 4 times the quantity of a negative x plus 5 is equal to 10. And when we distribute this negative 4 across, we will arrive at x plus 4x minus 20 is equal to 10. Combine the like terms, and we have 5x minus 20 is equal to 10. And let's get those numbers on one side and those variables like x on the other side by adding 20 to both sides. And what we have right here, we have 5x is equal to 30, and that begs a question again. What number times 5 will give me 30? And that's correct. The answer is 6. All right, and so x is equal to 6. And when we plug it into the other equation right here, we find that y is going to equal to a negative 1, because since x is 6, and we're just going to say a negative x, well, a minus 6. A negative 6 plus 5 will give me a negative 1. And when we plug it in, it all works. And yes, and our solution is at 6, comma, negative 1. All right, you received a lot of information, but that's okay. You can pause the video and give this thing a once-over, or replay this video as many times you need to gain a deeper understanding of how to use the substitution method to solve a system of two equations. But in the meantime, you can always comment, share, like, and then subscribe to Jack's Math Notebook for more content. Thank you and goodbye.